Okay, hello friends, welcome back to C for You. This video is about problems on Birch reduction. Let me tell you at the very first of this video that I'm not gonna go through a basic mechanism of Birch reduction and all the regioselectivity. Today we are going to solve some problems which are asked in CSIR net examination and IIT JAM examination, and which is useful for 12th chemistry also and for M.Sc also, M.Sc chemistry. Yeah. If you wanna go through the basic mechanisms, I have made another video. You can go through that video, whose link is given in description. Yeah. So now let's start with the first problem which I asked in my last video. You are given with 2,6 dimethyl pyridine, lithium in liquid ammonia, which is a Birch condition, H3O plus hydrolysis type condition, and KOH with MEOH, potassium hydroxide in methanol. Yeah, which is a base. Now the first options are given, where first where this carbon gets oxidized, then you get something like enone. Here is also enone, but which is open ring, and here is also enone, but methyl group is substituted at another position. Yeah. So now let's start with this example. So here is our problem. To solve this problem, you need to know three basic things, whose first is Birch reduction, which is our key topic of today's video. Then second one is the reactions of enamines, because after Birch reduction the enamine is going to form in this case. Yeah. And the third one is very important, which is a aldol condensation. And at the very first I'll tell you कि in this problem a special kind of reaction is going to take place, which is known as the Robinson's annulation. So I mean, in the same problem we are going to see three reactions. So let's start. You know the regioselectivity of Birch reduction. I'll write it here first. Yeah, the pyridine with two methyl groups, lithium comes with one electron, and this electron approaches this carbon so that a negative charge, that means anion, can be formed on the nitrogen, which is the most stable form of all resonating structures of this pyridine. You know this. Now ammonia itself act as a proton donor, proton source in this case, and hence the nitrogen gets protonated and you have one more radical. Now another lithium comes here, it gives it electron, and with source from ammonia with the same mechanism, I am just skipping one step here and I will directly write the final product. So this is what we are getting from the conditions of a Birch. Sorry. Yeah. Now this compound is going to be treated with H plus H2O, that is H3O plus, means acidic condition. Now you can see here is in amine form, which is known as enamine, and enamines, when are subjected to protons, okay, I'll write it separately, sorry. So here is the enamine product, one and one, yeah, hydrogen with, so yeah, with H plus H2O. I'll write the H3O plus in this form. Always remember, protons never appear as H plus. They always comes in the form of H3O plus only. Hence it is written like this. So this enamine gets protonated, and here is something. The new proton comes here. Previous hydrogens, double bond, methyl, methyl, hydrogen, and the newly formed double bond with positive charge on the nitrogen. Now, this carbon is very much electrophilic. The reason is, the first thing, nitrogen is electronegative, and another thing, nitrogen needs more electrons, so it would pull those from this carbon. So the carbon becomes more electronegative. We have, oh sorry, carbon becomes more electrophilic. Sorry, and we have a nucleophile, which is a water molecule. Attacks here. Yeah. So what is formed here? Yeah, methyl 1 OH H methyl double bond. Okay, so this is what we have. But always remember, a single carbon cannot borrow OH with NH or 2OH. We know what happens there. Yeah, this is what the condition, and this is what the speciality of enamines, how they form, what I say, ketones. So here you can say ketone is being formed like this one. Now we saw the condition of one side of enamine. Here, sorry, yeah, this goes like this one. Here also enamine is present, so the same reaction will takes place with H3O plus. Now I'll not write these all steps again, you can do it at yourself. I'll just write the final product, which would look like this thing. Okay, here is one methyl O, here is one methyl and O. This is the product of your second reagent. So we are done with Birch, we are done with hydrolysis. Now we are left with KOH methanol, which is a kind of aldol condensation. For aldol condensation, you have this kind of a dione, which is 1 2 3 4 5 1 5 dione. When 1 5 dione are subjected to KOH in methanol, KOH is what? Base. What it would do? It would abstract a proton, which is acidic. Now you have 1 and 2 positions, 1 and 2 positions, but out of those, these positions are more acidic. So out of this methyl, one methyl gets deprotonated and enolate is being formed there. You can write this enolate in this form also. Yeah. Minus and double bond. Now next, you have one carbonyl center. So I'll show you like this. Okay. So what is being formed here? A 6-membered ring, right? 1 2 3 4 5 6. 6-membered ring, and if I'll number it as 1 2 3 4 5 6, let it be 7, and I'll number this ring as 1 2 3 4 5 6. Yeah, so first position is here, it doesn't have anything. Second carbon have one carbon. 3 4 and 5 goes, 3 4 and 5 goes, then 6 carbon has one. What it has? It has one methyl and one OH, right? So right, we are there. Now in the next step, one of the hydrogen from here, goes like this one. With the dehydration step, you will get this product. So this is our final product. Now let's see if anything from the options match this one. No. Second option C. 1, 2 and 3. So 1, 2 and 3. Yeah. Okay. So guys, we solved one problem. And yeah, in Birch reaction we saw the Ridger selectivity. That means if you have something like electron withdrawing group, then how will reaction go, and if you'll have electron donating group, then how the reaction goes. Okay, we know this benzoic acid with NaNH3 or LiLH3 in alcohol would give you 2,5 product, I mean 2,5 diene product, and the anisole with the same conditions would give you 1,4 product. Yeah, but there is one exception. That means if someone will ask you to do the Birch reduction of this thing, NN-dimethyl aniline, then benzene ring with NMe2, and if you are given with NaNH3 conditions, then one might write the product as we know this one. Sorry, NMe2. Yeah, but guys, for this case, the compound becomes 1,3-diene. This is what the exception you have to remember. Okay, so now we have one more example with us. We have alpha naphthol. So the structure would be, yeah, okay, with NaNH3 and alcohol. Okay, now we have two aromatic rings, let's say A and B. Now out of these two rings, only one ring is going to be reduced. Then how to decide which would be reduced? So here is OH group present, which is electron donating group. The resonance of this OH group makes this ring electron rich. That means electron clouding of this ring becomes more, and as in Birch reduction, the coming electron is going to approach on your ring, so there would be electron deficient space, there will be electrophilic center in your ring. So in the B ring, which is not the case, and hence this ring only gets reduced like this. So this is what your product. We get one benzene ring reduced to the non-aromatic, and the aromatic of one ring which is attached to the OH group remains the same. Okay, so now we have another example of, let's say, yeah, we know in the Birch reduction alkynes reduced, but if you are given with any isolated alkene with sodium and with n conditions like ROH, the reaction doesn't go. If anyone will ask you such a case, then reaction doesn't go. But remember guys, if you will have a double bond in conjugation with another double bond, or let's say a phenyl ring, if you will have this kind of a thing with NaNH3 ROH, and even though if you have something like enone, then let's say this double bond is again in conjugation with carbonyl. So the electron from sodium, condition I'll write here, NaNH3, yeah, electron from sodium approaches this carbon, this goes here, and oxygen gets negative charge, oxyanion is being formed here, Okay, so this radical is there. Then one more electrons comes, makes an ion here, and firstly this O minus gets protonated with the source of proton in the reaction, so it becomes OH. Here is negative charge and here is double bond. Again, this negative charge, as we know in the Birch reduction, gets protonated and you are getting this product as a reduced one. Now we all know what it is called as. It is an enol, and enols undergo tautomerism to form a ketone. So finally, you are getting this product from enol. That means enol are directly reduced to the ketones in presence of sodium in ammonia, then in the conditions of a Birch. So this is our now we have one more example which is asked in a NET examination again. So okay, here we have the example where two cyclic rings are there. We have one enone system and an isolated double bond. As we see in our previous examples, isolated double bond is not going to reduce with the Birch conditions, so this remains the same. It is not going to be reduced. Okay, and then this enone, as we saw in the last example, this enone is going to reduce in a ketone form. So finally, we are getting this compound. And now, the stereochemistry of a coming hydrogen, it will be the same as in the opposite methyl group. So this would be the product. This example, this problem is from CSIR NET examination again. Okay, so yeah, one more I have. Uh, this example is from the IIT JAM question paper, which is very much similar to one we saw earlier. I guess yeah, it is here. Here is your double bond in conjugation. This double bond has extra methyl group, and in this example, you have just a double bond. We can say uh, vinylic carbon have phenyl group. Okay, so in conditions of a Birch, I'll directly write here Birch, you would be getting such a kind of a product. Yeah, so I hope you got many of the examples. And yeah, now I have another example for your practice. You do it on yourself. I'll come up with answers in my next video. Yeah, so here I go. This example I'm taking from Caruther. Sorry. Yeah. And the same with only NaNH3 without alcohol, and with alcohol and without alcohol. I'll give you a basic trick here. Okay, in absence of alcohol, Birch reduction goes slower. I have cleared this thing why it goes slower and all the things in my another video which is about the basic mechanism of Birch reduction. You can go there. But in absence of alcohol, but the Birch reduction of a aromatic ring of a benzene ring goes slower, and hence in this case this double bond, the product in which this double bond is reduced would be the major product, and in this case this all will get reduced. Yeah, sorry. I just told you with the trick. I came up with the answer. Don't worry, I have another problem. Yeah, you can go with it. So here we are getting this product. Okay. Yep. Yeah, I have one more problem which was asked in Pune University's question paper. So here is CH3C. You have a triple bond like alkyne then they are given with NaNH3 and methyl iodide. So now you have to solve this. What would be the product and how it goes. So do it at your own. Till then, enjoy your chemistry. I'll come up with its mechanism and its answer in my next video. Our next video will be on acetylene condensation. Till then, just stay tuned. Thank you for watching the video.